Okay, welcome back, and part two of our function lesson one. We're going to talk about evaluating functions from graphs. So let's take a look at these. Now, remember, if I go back, like finding g of 4, I just plug in into the equation and it's all easy. So how do I plug in if it's a graph is the basic idea. So here's the idea. When I'm looking back, if I want to find the output is another name for your dependent variable or your y variable or your range, for the input, which is your independent or your x. So basically in part A here, when it says I want an output, it means give me y when my input or my x is 4. So I'm going to go on the x-axis, 1, 2, 3, 4. It's right here. But I don't see a graph there. I just see, my axis. So I'm going to go until I see the red curve here. Okay, so here's the red curve. So what is the y value when the x is 4? Well, it's right here. It is this coordinate or this location right here. So when x is 4, y has a value of 3. So in other words, what I'm asking you for is the coordinate 4, 3. So here's the answers to all of these. You can kind of take a look at them as you wish. But the first one, like I said, when the input is 4, the output is 3. Let's look at part B. Find the inputs whose output is 0. This time, I gave you the output, I gave you y. So I'm looking where y is 0. Maybe you remember something in Algebra 2 called zeros of a function, roots, x-intercepts. That's what I'm asking you for here. When the output is 0, that means my y is 0, which means I'm looking for the zeros of the function. So what x values have y values of 0? Well, there's one right there, anytime it crosses the x-axis. So this graph contains a point -3, 0, 0, 0, and 2, 0. So my function f of x is 0 when x equals -2, 0, and I think I screwed that one up too. Let me look back at my graph. No, I'm good. No, I'm not good. It's at -3, 0, and 2. Okay, it's a bad day. Let's try that again. So let's try that and do it correctly this time. So f of x is 0 and x is -3, 0, and 2, which corresponds with this point, and that point. Now, find f of 1. Again, when I say f of 1, that means 1 is the x, give me the y. So here's where x is 1, find the graph. There's the point I'm looking for, 1, well, its y value is -2. So for part C, f of 1 gives me a y value of -2. If f of x is -2, then what does x equal? So again, here I'm going to go on the y-axis, and I'm going to go where y is -2. And I see this happens 2 times. There's one, there's the other. So when I say if f of x or if y is -2, what is x? So what x value has this y value of -2? Well, -4 does. And here is at 1. So I know that f of x or y is -2 when x is -4 or where x is 1. Here's a tricky one for you. F of -2. I go here to -2. Again, when I say find f of -2, it means I know x. My x is -2. What's the y? Well, the graph, it's got a hole there. That must mean, well, it's 1, right? Because that's the y value? No. Well, it's undefined because it's a hole. No. When I'm asking you to find f of -2, I'm not looking for holes, I'm looking for solid dots. So even though it's not part of like this curve, do you see the solid dot here? That is actually part of this function, so, or relation. We'll decide if it's a function or not later, but there are two locations that have a y or an x value of -2. One is here when y is 1. One is here when y is 3. I take the one that's the solid dot. So f of -2 is actually this dot, which is at 3. Okay, let's talk domain and range. In your Algebra 2 class, you probably talked about interval notation, set builder notation, inequality notation, all that jazz. I'm a big fan of interval notation, so let's go with that. So I see that for my domain, the first x, I see there's no x values, no red function out here. It doesn't start until -4. And it has a solid dot, which means I'm going to include it. So I go from -4, and I'm just going to trace along here. There's when x is -3. We're still good. Whoops. X is -2. Bad. I got a hole here. Think of it like this. Say you're going to a movie with a buddy, and let's say you say, oh, crud, I forgot my wallet. I don't have any cash to get in. Well, you'd have a problem unless you got a buddy to hook you up and say, you know what? Hey, I got your back. I'll cover for you. You get me next time, kind of like that. That's what's happening here. Even though there is no value of -2 for x here, this guy at -2, 3 says, I got you covered. And then x here, x at 0, half, 1, 2. So basically, every x value is covered on here from -4 all the way to the x value of 5. This hole gets filled by that y coordinate in the x. Or you can think of it like is, if I went and took this thing and squished it and made it flat on the x-axis, everything would be covered. So my domain is all coordinates between -4 and 5 included, because it does have solid dots on the endpoints. Now the range. Well, the lowest y value, there's nothing down here. The y values start, well, there's like a value, there's a value, so starts at -2 and goes up. And this hole is covered by, well, like a point right here. It basically contains all values from -2 all the way up to the highest y value of 3. So my range is from -2 to 3. And again, I use brackets because solid points, solid points. Lastly, is it a function? Is it a one-to-one function? Well, to be a function, it has to pass a vertical line test. Vertical line here crosses once, 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 once. What about at 2? At -2, I'm sorry. Here it looks like, well, it crosses the graph here and it crosses here. So some would say it's not a function because it crosses both here and here. That's wrong. This hole is not there. It's not part of the graph. It's not there at all, basically. So I only cross one point on a graph here. So it is a function. It does pass the vertical line test because I have a dot, and then if I had two solid dots here, then no, it would not be a function. But this does pass the vertical line test. Does it pass the horizontal? No, I could draw a horizontal line right here, or heck, the x-axis crosses 1, 2, 3 different values here. So it is one-to-one. It is a function. It is not one-to-one. It passes vertical line test. It fails horizontal. Take a little bit of time, and I'm going to suggest that you guys pause this video and take a shot at these on your own. I've given you a graph of f of x and asked you to find a few things. Let's see if you can do just that. So let's look. F of 2, that's my x value is 2, so I go 1, 2 on x. I find the curve, it gives me right here. What's its y value? Well, it looks like its y value is 1, 2, so negative 3. So f of 2 is negative 3. F of 0, that doesn't mean when is y 0, it means when is x equal to 0, which is on the y-axis. So when x equals 0, I got a hole here, not going to count it. Got a dot here, that absolutely counts. It has a y value of 1, 2, 3, 4, 5. So part B, f of 0 is 5. Part C, f of negative 4. 1, 2, 3, 4. Oh, I see this thing going on forever like an asymptote. That's no good. This goes down. It's an asymptote. That's no good. Oh, dot. That's what I'm looking for. So at 1, 2, 3, negative 4, I got a dot with a y-coordinate of negative 2. So f of negative 4 is negative 2. F of 4. So 1, 2, 3, 4 for x. I got two holes. So there's not something one of these guys doesn't cover for the other one. There's no solid dot, so I say that f of 4 is undefined. There is no solid dot. There is no y value when x is 4. Now the domain of this one's a little creepy. What I look at is, okay, how far to the left do I go? Well, I go all the way out. You see this arrow here? I'm going all the way out to negative infinity. Now, if you remember in the problem before how I had the brackets because it equaled, you can't equal an infinity, and infinity goes on forever. So if you look at how I wrote my domain, the negative infinity, I started with a parenthesis. That tells me I cannot equal it. I just go out forever and ever and ever. Now, I'm good for a while here. I'm at negative infinity. I get to here. So, oh, nope, not covered here because of this asymptote. No, oh, the dot covers for it. And then it continues. And then I hit a hole here. So, no, wait a minute. This is that movie theater thing, you know. If I don't have money for the movie, if my friend covers for me, we're good. This guy doesn't have any friends. There are no solid dots here, so this value of 1, 2, 3, negative 3 for x is not part of my domain. So how do I write that in interval notation? Did I do that right? 1, 2, oh gosh. Forgive my problems here. Should have probably proofread this before doing the video. Live and learn, I guess. Let's try that again. So I'm good except for this hole here for x at 1, 2, negative 3. So I go from negative infinity up to that negative 3, which I don't equal. This weird little u thing is called a union, meaning here's the first part of my curve. Let's pick it up again at negative 3. Again, I have a parenthesis and a parenthesis. That means go from negative infinity, hit 3, skip it, and I'm going to keep going till I hit 3. Let's see what happens there. So if I go back again, good here, negative infinity, covered at negative 4, still good, negative 3, bad. Then I go to here. I see a hole here when x is 0, but no, this guy covers for me. And then I'm good till I hit here at 1, 2, 3, 4. Okay, let's just type a whole bunch wrong. That just sounds like a fun thing to do. All right, let's try this one more time. So I go to negative infinity. I'm good until I hit 3. So I put the negative 3 in parentheses. I don't include it. I skip. I don't include it. And then 4 is bad, so because there's no dot here. So I skip the 4, and then I keep going, and you see how this arrow is pointing right to infinity. So my domain is I start at negative infinity. I'm good till I hit negative 3. So this is how you say in interval notation, I'm going to skip it. And then I'm good till I hit 4. Then I skip 4. and then I go on for infinity. Okay. Couple things for you to play with. Again, I give you square roots because I care enough to hate. I know it's an area where people struggle and they freak out. Do your thing. Take a shot at finding f of 3, f of -5, and f of 0. Again, plain simple. When you're given an equation, direct substitution, plug in. So f of 3, I'm going to replace this x with a 3. So I get the square root of 3 squared plus 1. 3 squared is not 6. 3 squared is 3 times 3, 9. And 9 plus 1 gives me root 10. Do not give me a decimal. I despise decimals. Root 10 is just fine in my world. We're done. Okay, f of -5, again, I plug in -5 where the x was. -5 squared is 25 plus the 1, root 26, let it be. Now there are times when you can simplify a radical. We'll get to those in another lesson. And then lastly, f of 0, I replace every x with a 0. 0 plus 1 is square root of 1, and the square root of 1 is 1. And we're good to go. F of m plus 3. What do? I replace every x, so instead of square root of x squared plus 1, I plug in the m plus 3. Again, we're going to have that same issue. I'm going to let you work it out on your own, but since this is a binomial, I just gave you the final answer. You can show the work. We've done enough of that in the other part of the lesson, so I take m plus 3 times m plus 3 and I FOIL it. That gives me m squared plus 6m plus 9. And then I combine the 9 with the 1. See if you can get that answer. If not, very good question to raise when we have our class time. And the last thing, I promise you a little bit of calculus. I give you a little bit of calculus. This weird little formula here, part C, f of x plus h minus f of x over h, is a little thing called the difference quotient. You say, what does that mean? Well, a difference means to subtract, and you'll notice on the top there is subtraction. Quotient means to divide. We're dividing by h. Now, we're not going to do the whole deal where you find the instantaneous rate of change or the first derivative. I'm not going to do that with you yet. I just want you to get used to the algebra part of it so that when we talk about limits, I can show you how to use the difference quotient to find that. So we can do this all in one shot if you want, but I think most people are going to find it's easier to start little piece by piece. So here's my f of x. First thing, if I'm going to find this deal, I'm going to start by just finding f of x plus h. What does that mean? It means I'm going to substitute this x are both going to get replaced with x plus h. So instead of x squared, I get x plus h squared. Minus, instead of h, I minus the quantity x plus h. These parentheses are absolutely important because you're going to have to distribute that negative. Again, x plus h is a binomial. When you square it, you need to FOIL. So I distributed this negative, and then when I FOIL this, I'm going to take, well, watch as I say this, I'm going to get x times x, which is x squared, x times h, which is xh, h times x, which is hx, or xh, it's the same thing. Whether you do 2 times 3 or 3 times 2, they both give you the same thing. It's called the commutative property of multiplication. And then h times h is h squared. So this part is going to FOIL out to x squared plus 2xh's plus h squared. And then I look for like terms. Here's an x squared. No. This xh, again, this xh and this xh makes it 2xh. There's none of those. H squared and x. There's no like terms here. That thing looks awful. Here's what I'm going to tell you. When you're doing this first part, finding f of x plus h, if you find that nothing cancels and it looks awful, you probably did this first step right. The canceling is going to come when I do the second part. Here I'm asking you to take f of x plus h, which we just found it's, well, that awful looking thing right there. And I'm asking you to subtract f of x. You say, well, what's f of x? F of x is this. So I'm going to take what we did in part A, and then I'm going to subtract the original function. So it's going to look like this. So, there we go. Much better. Again, proofreading would have been awesome. So, f of x plus h was that nasty thing we found at the beginning, and then f of x is our original function, which is that. So I'm going to take the big nasty thing we did in part A that nothing canceled, and I'm going to subtract the original function, so I'm going to have to distribute this negative. So the x squareds will become negative, the negative x will become positive, and the plus 2 will become negative 2. And the cool part about this is, remember I said after that first step, just finding f of x plus h, it's going to be awful and nothing cancels. When you do the second step and you take the f of x plus h and you subtract the original function, a lot of stuff's going to cancel. The x squareds are gone. The x's are gone. The 2's are gone, leaving me with that. And then lastly, part C, I take f of x plus h, which we found, subtract the f of x, which we just did, and then I divide by h. So I'm going to take what I got in part B and just divide by h. Now what I see is on top, everything has an h, so I'm going to factor out an h. So 2xh, if I take out an h, leaves me with 2x. H squared, if I take out an h, still leaves me with 1h. And h, take out an h, leaves me with 1. These two h's will cancel. And my function, my difference quotient is evaluated. So what does f of x plus h minus f of x all over h equal in this particular instance? It equals 2x plus h minus 1. I leave you with one more to play with, and I'm going to let you do this one on your own this time. If you can just jump right to part C and just do that as one whole deal, you have my blessing to do it. If you need to take it step by step to get to finishing part C, that's fine, but I'm wanting you to, the punchline here is, I want you to give me the difference quotient, what that equals. So work on this, and it's probably a good thing for us to go over when we have class next time. So I will stop there, and there is an assignment in your folder in Schoology for the first assignment. So it's lesson 1 assignment. I believe there are 14 problems. Have fun. I'll see you in class. Bye, kids.